Section 5-4 is on factoring. Number 16, the type of factoring you need to do here is you're taking out your greatest common factor. So between 6 and 18, your GCF would be 6. Between a squared and a would be a. B squared and b cubed, the greatest number of b's in common would only be 2. And then what's left, you use the distributive property. We have to say 6ab squared times what is a squared, 6a squared b squared. So we'd have to take it times another a. And you can check your answer, and you should get 6a squared b squared. On the next term, we have to say 6 times what is 18? Well, 6 times 3 is 18. A times 1 gives you a, so we don't need to write anything after the 3. B squared times another b gives us b cubed. And again, you can check your answer and make sure you do get 18a b cubed when you distribute. The next type of factoring on 22 is a trinomial. The y squared came from the f of FOIL, the 5y came from OI of FOIL, and the 4 came from the L of FOIL. So when we factor this, these are actually easier when the leading coefficient is a 1, because the only way to get y squared is y times y. Then we can look at this number here, and we can say factors of 4 that add up to 5. Factors of 4 that add up to 5, which would be 4 and 1. And since we need a negative 5, we need a negative 4 and a negative 1 to come up with the outer and the inner terms. Then you have factored that completely. Number 26 is a tougher problem than 22 because the leading coefficient is a 12. But remember, 12m squared came from the f of FOIL, negative 1 came from the OI of FOIL, and then the 6 came from the L of FOIL. There is no greatest common factor to come up with, so now it's a matter of trial and error. To get 12m squared, we could take 4m times 3m, and then we'd have to maneuver the 6 and the 1 to go in the last spots, factors of 6. So we could go 1 and 6, but then this would give us 3m, and this would give us 24m, which does not work. So we can cross that off. Our next option, we could take 4m, use the 4m, and use the 3m, and try maybe switching the numbers around, like 6 and 1. And when you do that, you get 18m for your inner, and 4m, which do not work. How about then we try 4m and 3m, and let's try 2 and 3. If I put a 3 here and a 2 here, I get 9m and 8m. This time, we do get a difference of 1 in the middle here, and since we want a negative 1, we need a negative 9 and a positive 8. So we would make this negative 3 and a positive 2. So this right here is our answer. Number 32, we do have a greatest common factor. So we need to take out a 3 first. And then we have m squared minus n squared. What's left can be factored further because it's a difference of perfect squares. Anytime you have a perfect square minus a perfect square, 1 is plus, 1 is minus. M squared came from the f of FOIL, so you go m and m. N squared came from the L of FOIL, so you would go n times n. And then this right here would be your final answer. Number 36 is a difference of 2 cubes. You need to remember this formula, a minus b times a squared plus ab plus b squared. You use this whenever you have a cubed minus b cubed. So identify what a is and b is. In this case, a is t, and b, well, b would actually be 2 cubed. Well, b is actually the 2. And then we can follow the formula. So we have a minus b, or t minus 2, a squared, which would be t squared, plus a times b, which is 2t, plus b squared, which is 4. You can never factor this further, so then you are good to go. Our last example looks a little bit different, and you're asked to simplify. So what we have to do is factor the top and factor the bottom. Again, these are going to be easier to factor because your leading coefficient is a 1. So this came from the F-foil, OI-foil, and then L-foil. So to get x squared, it would have to be x times x. Factors of 3 that add up to 4 are 3 and 1. Both signs are plus to give you a 4x. In the denominator, this is F, OI, and L-foil. So x squared came from the F-foil, so again, we'd have x times x. Now with this one, we have factors of 12 that have a difference of 1. So that would be 4 and 3. And since our outer and inner have a negative 1, we need a negative 4 plus 3. What you do next is then you look to cancel like factors. X plus 3 cancels with x plus 3, and you are left with x plus 1 over x minus 4. And that would be your answer for that simplifying.